The definitions for the error discussed before can be extended to the case when the exact answer or approximations is in vector or matrix form by measuring the norm of the vectors or matrix. So we're gonna discuss some vectors norm in this part. Suppose that both x and y are vectors, where y is the approximate result while x is the true result. Then the absolute error can be defined as a norm for the difference between vectors x and y, while the relative error is a norm for the difference between vector x and y divided by the norm of vectors x. The value of the error will depend on the norm that is chosen. A norm must satisfy 4 basic properties. That is, norm is a real value function that provides a strictly positive size or length of vectors and matrices, the first properties. Except for the zero vector, the length of the vector will be 0, the second properties. A norm must also satisfy the triangle's inequalities, that is the third properties. And finally, it has to be being absolutely scalable, the fourth properties. Now, let's look at L1 norm. The L1 norm is the sum of all absolute value of the entries in the vector. For example, to find the L1 norms for vector x, which with 1, minus 2, minus 3 as its entry, we're going to sum up the absolute value of each entry. For this case, the L1 norm is 6. While the L2 norm or the Euclidean norm can be expressed as a square root of the sum of all vectors entries squared. For example, to find the L2 norm for vector x, which with 1, minus 2, minus 3 as its elements, we're going to sum up the square value of each entry and find their square root. For this case, the L2 norm is 14. The maximum or infinity norm is defined as the largest absolute value of the elements in a vector. For example, to find the maximum norm for vector x, which with 1, minus 2, minus 3 as its entry, we pick the largest absolute value of the vector's elements. So the maximum norm for this example is 3. In general, the LP norm can be written as follows, where P is greater or equal to 1. Now, for the same vector, let P to be 3. We can get the L3 norm as 3.3019. Lastly, we like to conclude here with the fact that the norms are nested, where L1 norm will always greater or equal to L2 norm, L2 norm will always greater or equal to L3 norms, and so on.